In the previous video, we talked about the air conditioner and sizing of the electrical system. In this video, I thought I'd talk a little bit about the battery selection and wire sizing. So you can see that we have different wire gauges and the max amps that is recommended. I got these numbers from an electrical website. Then the inverter that I have is a 3000 watt inverter, continuous, 24 volts. That's a max amp draw of 125. At peak though, we can be pulling 250 amps, twice that much. The battery's continuous current limit is 100 amps, but they can do a max for 30 seconds of 200 amps. I'm using the Battleborn batteries. They're made very well, and their support is excellent. I'll explain what I did in 2.0 or 1.0 here. I had 6 12-volt batteries with 3 chains. They recommend that you not connect this midpoint together at all. You want 3 separate chains, so if one of the batteries in one of these chains goes bad, it does not take out the other 2 chains. I'll explain something that I did wrong in version 1.0. I have a few 12-volt loads. They're not very big loads. Most everything that I have that's big is 24 volt. But to provide 12 volts to the DC distributions, I just kind of tapped off of one of these batteries at the bottom of the chain, of one of the chains. Well, I turned on the fantastic fan and left it running. And what happened was, even though I have solar panels charging this whole system, this 12-volt battery was drained down to the lower threshold, and that is not good for the batteries. What I ended up doing was blowing up one of these batteries. My fault. I killed it. So in version 2.0, and I think what's happening too is why he never got recharged was, as soon as the top battery is full, it cuts current all the way. So as soon as this guy is full, he stops current. He's got a BMS system that's on board, and the current is stopped here. So this lower battery never got charged back up, because in general the RV was not using the full 24 volt system very much. I should say the van wasn't using the full 24 volts. So this guy never got drained, and therefore he never allowed current to charge the lower battery. Okay, so in 2.0 what I'm doing is I'm just gonna replace, I actually had 2 of these guys go out. I think when this one went out, it kind of messed up the system with another one. Anyway, Battleborn hooked me up. I told them what I did. They said, how about we split the cost with you? And so I got 2 replacement batteries for the price of 1, and that was nice of them. I fully acknowledge that this is not the right way to do it. So what I have now is I have a DC to DC converter, 24 to 12 volts, and then I run all of my 12 volt loads from this DC converter. The batteries that I got to replace them are 24 volters. Right, they're the exact same form factor as these 12 volts. Well, for the most part, they're the same form factor, although the leads are different. You can see this on their Battleborn website. The remaining 2 chains, I now have voltage meters that go to the midpoint and monitor if these guys dip too low and they're not getting charged back up. I can manually stick a battery charger across just these two leads and get them back up to be balanced with the upper battery. So I think this is a pretty good, and I don't really expect them to dip like I did when I did this foolish mistake. Anyway, next thing is what I did was I said, all right, how big are the wires that I need to connect all these guys to? So if we take the worst case condition, this 250 amps, and we divide it by 3 because we have 3 separate chains, then we get 83 amps from each of the chains. 83 amps is less than 100, so we take the next one up, and so I'm going to use a 6 gauge wire to connect all these guys. And then at this point where they all come together, and at this point it goes to the inverter, I'm going to be using, for this 250, I'm going to be using double aught. I could probably get away with single aught, but I have double aught ready to go. So that's what I'm using. So next part of this video. So the next part of this video is putting all of these batteries and everything into a battery box. This video is going to be going over the battery box and inverter. So you can see down on the bottom I have three sections. Each one of those is big enough to hold 2 batteries, and I have a cooling fan installed. So the top section will have the inverter, and I have a cooling fan right here, and then here will be a door to mess with the inverter if needed. And then finally we have several switches and a USB plug, AC port. All of this stuff needs to get wired into the power points that I have back here, and then those power points attached to the wall. In addition, I have most of the electronics laid out and mounted to the wall. I got your standard household panel and the inverter, and all that stuff is tied in with some major hardware. I have another video that covers this, but we still have a couple of things left over, which is basically all the batteries that are in the bottom of that battery box need to be hooked into this inverter and then tied in with the DC portion of this electronics panel. So that's what we're going to do. Those components can be seen here. I'll have a relay and a temp sensor that go to a microcontroller that will turn on the fans located there that start to cool off the inside of the box. I have a main DC cutoff, a fuse, bus bar, positive, negative bus bar, battery voltage monitor, BMS system, and then finally we have another fuse back here, which is kind of a weird looking dude, but he comes from the solar panels and the solar panel MPPT controller, which was mounted on the wall. So I'm going to break all this stuff apart and try to figure out how to do its layout. I kind of have a rough sketch over here of what's going on, but you know, making it work, that's a whole nother story. We have our 12 volt to 5 volt converter for the temperature sensor. This does humidity as well. And then we have a relay here to turn on the fans for the battery box.
And this stuff is going to be mounted on the bottom of the shelf, and on the top of the shelf is all of our high current electronics. So put this into the battery box, get the shelves put in, and then we'll install it. Alright, one more look at this thing before we stick it in the van. Get it bolted in. You can see the fans on the front. I have all of those guys wired up together in parallel, and then into the relay board, and the relay board over to the terminal block, which will provide power. On the top here I have the main on-off battery disconnect, a couple of bus bars. I have a fuse, inline fuse for the alternator charging. MPPT controller, it's another fuse. Just put your MPPT output on that thing. A main fuse, it's 150 amps. We've got AC and the USB charging, along with some switches here for things that are going to go in the cabinet above it, which we'll get to, but it's ready for batteries. So let's go stick it in there. So here you can see I've got all the batteries in the bottom on the shelves. It took me a pretty considerable amount of time to get all those wires cut properly, lugged, and screwed onto the batteries. You can see on the bottom two shelves I have two 12-volt in line with each other in series to create my 24 volts. So I got 24 volt, two 12 volts in series on the top and bottom. And then I have two 24 volts on the top. You can also see that I have a 6 amp or 6 gauge wire, and then from the common 24 volt lug I have a 2-aught wire going into the cutoff switch, and then I have 2-aught wire going up into the inverter as well. In addition, I wanted to monitor that midpoint on those two 12 volt chains, and so you can see they're at 13.4 and 13.2, and in case I needed to charge them, I have two wires coming out which I'm going to lug and screw into this cabinet somehow, so that I can manually charge those if I needed to. And then last thing I need to do, and I'm not going to document this, I have a wire coming up from the engine battery, and I have another switch which I'm going to put in that'll allow me to start the van in case of an emergency. But generally that's last resort. What else? Oh, so coming out of the so this is kind of like the big DC section. You got your shunt, which measures current for your BMS, and then coming off of there I have two wires that come up here, and that takes you up to the DC distribution panel and the MPPT and all of that. So I have a link to the video how I did all that. Yeah, so I'm going to call this done for now and get on with the next thing.